Welcome to our module on laboratory data management and reporting, a crucial aspect of modern lab operations. We will explore how to ensure the integrity, security, and transformation of data into actionable insights effectively. Today, we will focus on understanding master data within a laboratory information management system or LIMS. This foundational data provides the stable framework that consistently guides all laboratory operations. Master data serves as the core reference, defining how the entire LIMS system operates. It dictates how the system processes and manages all incoming laboratory data. Unlike frequently changing transactional data, master data remains stable and highly structured. Its consistent nature means it changes infrequently, providing a reliable operational base. Master data connects various dimensions of the lab ecosystem, including scientific and operational aspects. It also integrates the crucial regulatory dimensions, ensuring comprehensive data management. In regulated environments, master data management is not optional. It is a regulatory necessity. Proper master data is critical for achieving and maintaining compliance with industry standards. Let us now look at the key categories of master data that are essential for robust LIMS operations. This information is fundamental for ensuring efficiency and accuracy in the laboratory. Test methods are a vital category, outlining the procedures for conducting experiments. These methods precisely define how each test is to be performed in the lab. They also set the specific acceptance criteria, which determine if results meet quality standards. Sample types define the various categories of materials that are tested within the laboratory. This classification helps organize and manage different materials undergoing analysis. Properly defined sample types guide the application of appropriate workflows automatically. Instruments represent another critical master data category, tracking equipment details. This includes important metadata about each piece of equipment used for testing. Instrument data ensures that all results can be traced back to a qualified instrument. User accounts are essential master data, defining who can perform specific actions. These accounts clearly define the roles and allowed actions for each user in the system. This critical control prevents unauthorized changes to sensitive laboratory data and configurations. Now, let us examine the typical lifecycle management process for master data within a LIMS. The lifecycle begins with the creation of new master data, such as a test specification. After creation, the master data undergoes a thorough review by peers or supervisors for accuracy. Once reviewed, the master data requires formal approval by the designated quality assurance authority. Regular maintenance is crucial to ensure that master data remains current and accurate over time. Finally, master data is retired or archived when it is no longer valid or needed. Now, let us discuss the significant risks that laboratories face due to poor master data management. These risks have profound impacts on both data integrity and the laboratory's overall regulatory compliance. One common issue is having duplicate methods, which can create significant problems. Well, duplicate methods often lead to considerable confusion among analysts and throughout the laboratory. More importantly, they cause inconsistent results, making it difficult to trust the data generated. Another critical risk involves using wrong specifications for tests or products. Incorrect specifications can unfortunately lead to making entirely wrong decisions about product quality or release. In regulated environments, using wrong specifications can even result in the false release of non-compliant products. Furthermore, missing instrument calibration information poses a serious risk to data reliability. Lack of proper calibration records essentially invalidates any test data produced by that instrument. Ultimately, this directly compromises the accuracy and trustworthiness of all the analytical results. Finally, inconsistent vocabularies, like different units of measure, create significant challenges. Such inconsistencies make it very difficult to generate accurate and standardized reports across the lab. They also create difficulties when attempting to identify trends or perform comparative analysis of data. We will now discuss the CIA triad of data security, fundamental pillars for LIMS data protection. These principles ensure the confidentiality, integrity, and availability of sensitive lab information. Confidentiality means that data should only be accessible to authorized individuals within the system. This principle ensures that sensitive information is protected from unauthorized viewing or access. Integrity ensures that data remains accurate, consistent, and free from unauthorized modification or alteration. This guarantees the trustworthiness and reliability of all laboratory results and records. Availability ensures that data is accessible and usable when needed for laboratory operations and decision-making. This means the system and its data are reliably operational to support ongoing work. Let us explore various LIMS access control models, which define how users interact with data. These models are crucial for maintaining data security and regulatory compliance in laboratories. With the specific job role, this model ensures that access is precisely tailored to an individual's responsibilities. Attribute-based access control determines access based on various attributes like location or time. This dynamic model allows for highly flexible and context-aware security policies. Discretionary access control allows the data owner to grant or revoke access permissions. This provides flexibility, but also places responsibility on individual data owners. Mandatory access control involves system-enforced rules for environments requiring high security. These strict, unchangeable rules ensure maximum protection for critical data. Let us now look at the many significant benefits of implementing automated reporting in a laboratory. Automation ensures that all reports are consistently delivered on time, are highly consistent, and are always audit-ready. One key benefit comes from scheduled reports, which provide regular, automated data delivery. These reports are automatically generated and emailed to relevant stakeholders, ensuring everyone stays informed effortlessly. This consistent distribution guarantees a regular and predictable flow of essential information across the organization. Another powerful feature is trigger-based reports, which respond to specific events in real time. These reports are automatically generated immediately when specific predefined events or conditions occur. This provides immediate alerts for any anomalies or deviations, allowing for quick and decisive action. Finally, utilizing standardized templates for all reports offers significant advantages. These templates ensure that all reports meet strict regulatory requirements, promoting consistent compliance. They also guarantee consistent report formats across all departments, enhancing clarity and professionalism. Now, let us review a standard operating procedure, or SOP, for audit trail management. This structured approach is fundamental for ensuring robust data integrity within the laboratory. The first task is to establish a clear audit trail policy for the entire laboratory system. A major step is to define the purpose and scope of the audit trail policy carefully. This involves explaining why audit trails are necessary for data integrity and accountability. It also identifies the specific systems and records that are covered by the audit trail. Next, a major step is to clearly assign responsibilities for audit trail management. This includes designating data stewards and quality assurance or QA reviewers. It also requires defining the specific roles and duties of system administrators. The next task is to implement the necessary procedures for effective audit trail management. A major step involves enabling the audit trail functionality across the LIMS. This means activating it in all LIMS modules to capture every relevant action. It is crucial to ensure that users cannot disable the audit trail functionality themselves. A major step is to mandate a reason for change for any data modifications. This requires users to provide justification for all alterations to data records. It also involves capturing secure electronic signatures for every significant change. Finally, a major step is to document all reviews and establish retention policies. This means recording all audit trail reviews in controlled and secure logs. It is also vital to retain these audit trails for the full record lifecycle as required. Today, we will explore the essential concepts of traceability and chain of custody, vital for maintaining data integrity in laboratories. These core concepts are fundamental for ensuring the complete integrity and reliability of all samples throughout their life cycle. First, let us define traceability, which is a crucial component in laboratory data management. Traceability gives us the ability to fully track the history, application, and precise location of any sample or data element. This capability ensures that every test result can be directly linked back to its original sample, instrument, and method. Next, we have the chain of custody, another critical aspect of sample management. It refers to a documented, unbroken trail of responsibility for a sample from its origin to its final disposal. This process establishes clear accountability for every individual who handles the sample during its entire journey. To conclude, let us summarize the key takeaways for effective laboratory data management. These points highlight the most important aspects we have covered in this module. Remember, master data forms the fundamental foundation for all LIMS operations. The CIA triad of confidentiality, integrity, and availability guides data security principles. Role-based access control and strong authentication are vital for protecting LIMS data. Reports and dashboards are crucial for transforming raw data into actionable insights effectively. Audit trails provide critical evidence of data integrity, ensuring accountability for all actions. Traceability and chain of custody are essential for ensuring complete sample history and security.